Okay, we're going to be looking at the test you took. You will have two versions of the test. I'm going to go through the first version of the test, and if you have a different version, the numbers may be slightly different. So, to begin with, we have these questions. Most people have got these right. 4 squared, 4 times 4 is 16. 4 to the power of 0, well, anything to the power of 0 is 1. 4 to the power of minus 3, well, the negative indice there means you take the reciprocal, so it's really 1 over 4 cubed. 1 over 4 cubed is 1 over 4 times 4 times 4, which is 1 over 64. Okay, this one here, we can do it in two ways. I'll show you one way and a second way. So the first way is to say, well, this is really 16 times by 1 over 64. 16 times by 1 over 64 is a quarter. Okay? A better way to do this, though, is to realise that because the base is the same, it means we can add the indices. So we have 4 squared times 4 to the minus 3. So it means it's 4 to the power of 2 minus 3, which is 4 to the power of minus 1. 4 to the power of minus 1 is just 1 over 4 to the 1, which is 1 over 4. Okay, this one down here, there are a couple of ways you could do it. You could do the power in the brackets first, so 4 squared is 16. 16 to the power of half. Well, to the power of half means the square root, so it's the square root of 16, which is 4, not 8, as many people will have written. Another way to do this is to realise that we have something of the form x to the a to the b. So when we have x to the a to the b, we times the indices together. So in this case we have 2 times 0.5, which is 4 to the 1, so the answer is just 4. Okay. Okay, next question then. In this question, what I'd like to focus on is how to set out your algebraic syntax, how to write algebra properly. So at this stage here, we're going to square root both sides, and we get the answer x is equal to plus or minus 5. In this second question here, we are going to divide through by 3 before we square root. Okay, we have to undo things in the reverse order. So x got squared, then multiplied by 3. So first thing we do is divide by 3 to give us 49. The square root of 49 is plus or minus 7. Okay, that's the answer there. This is how you should set out your work as well. You should have equal signs all in line as you go down the page. Okay, you shouldn't write 147 divided by 3 square rooted. That shouldn't be your working. Your working should be as I've written it. Okay, looking at this one then, the first thing you do is you add 7 to get 128. Then you're going to divide by 2 to get 64. Then you take the square root of both sides to give you x equal to plus or minus 8. Again, this is how you should set out your own working. So if you haven't done this, you should really correct this question. Okay, next question. Okay, so we've got this diagram, we've got two lines. The first line is line n. On the line there, I've drawn the gradient. The rise divided by the run is 2 divided by 1, so the gradient is 2. So we have y equals 2x, and because it goes through the point minus 3, it's y equals 2x minus 3. Y equals mx plus c. M is the gradient, c is the y-intercept. The line m has a gradient of, well, the rise is 1, the run is 3, so the gradient's a third. So we have y equals a third x, and it goes through 2, so it's a third x plus 2. No one would have got this wrong, I hope, so the point where they intersect is the point 3,3. Another line that passes through 3,3, there are lots of them, infinitely many in fact, but a couple of examples are y equals x, that goes through, y equals 3 goes through the point 3,3, x equals 3 also goes to the point 3,3, or maybe even this line here. This line has a gradient of minus 1 and goes through 6, so it's y equals minus 6, x plus 6. Okay, final question from paper 1. We're given some information, and we're going to use that information to work out some of these questions. So 3 to the power minus 10, we know 3 to the 10 is 59049. 3 to the power minus 10 means we take the reciprocal, so it's 1 divided by 3 to the power of 10. So it's 1 divided by 59049. 1024 to the power of a tenth. Well, that's the 10th root of 1024, which is equal to 2. Excellent. This question here, 1024 to the power of minus a tenth. Okay, so this negative sign here means we take the reciprocal, so it's 1 divided by the 10th root of 1024, and we already know the 10th root of 1024 is 2, so it's 1 divided by 2. This question is 59049 to the power of minus 3 tenths. Okay, that negative sign takes the reciprocal first, so we're going to have 1 divided by 59049 to the power of 3 tenths. The power of 3 tenths is the 10th root cubed. So it's 1 divided by the 10th root cubed. The 10th root of 59049 is 3. 3 cubed is 27. So the answer ends up being 1 divided by 27. Intermediary step might be 1 divided by 3 cubed. Okay, this final question here, the negative sign again takes the reciprocal. The reciprocal of the fraction is the flipped fraction, I guess. So it's 59049 divided by 1024 to the power of 2 tenths. 2 tenths is the 10th root squared. The 10th root of the numerator is 3. The 10th root of the denominator is 2. And then we're going to square it. When we square 3 over 2, we get 9 over 4. Now, notice that this question was the question from the first paper. If you had the second paper and you wrote the answer 9 over 4, we know that you checked your answer with someone else. So, I think the answer for the second paper was actually 27 over, must have been 8. So 27 over 8 was the answer for the second paper, by similar logic. Okay, next question. This is the first question, well, it's actually the second question from the second test. I decided to skip the first question. So the second question from the second test. So we add the indices in the first question to get h to the 12. In the second question here, we add the indices in the numerator to get a to the power of 4. And we're dividing by a to the 11, so we're going to subtract the indices there. 4 take away 11 is a to the minus 7. Okay, some people wrote in these questions 2h to the 12 and 2a to the minus 7 or something, but that can't be right. You can't do that. So don't. Part C here, we're going to look at the numerator again. 6 times 3 is 18. And then p to the squared times p to the 4, where you add the indices to get p to the 6, and then divide by 2p. When we simplify this, 18 divided by 2 is 9. P to the 6 divided by p is p to the 5. Okay, because p on its own is like p to the 1. Part D. Okay, so 3q to the 4 cubed literally means 3q to the 4 times 3q to the 4 times 3q to the 4. Okay, so 3 times 3 times 3 is 27. Q to the 4 times q to the 4 times q to the 4 is q to the 12. So that's the answer to this question here. Okay, the next question, if you fill out, you can either use the table function on your calculator or you can work it out by hand, but this is what the table of values should look like. You plot the points, okay, and then you are going to draw a curved line through the points. You are not going to connect the points with straight lines. It is a curve, not a series of straight lines. Okay, so you should have a nice curve that looks something like that. Okay? Next question. Okay, so we have write down the gradient of this line, 2y minus 3x is equal to 8. Now remember, we like y equals mx plus c. We don't like it if it's not like that, so we're going to make it look like that. Okay? We like it when it's y equals mx plus c because m is the gradient and c is the y-intercept. At the moment we have 2y minus 3x equals 8. It doesn't look anything like y equals mx plus c. But we can rearrange. So we're going to add 3x to both sides. Okay, and then we're going to, it still doesn't look like y equals mx plus c. In order to make it look like y equals mx plus c, we're going to divide both sides by 2. When we divide both sides by 2, we get y. We're going to get y is equal to 3 divided by 2x plus 4. So 3 over 2 is the gradient. If you got this incorrect, it's because you didn't rearrange. You must rearrange. You can't say the gradient is minus 3. That is not the gradient. Okay. Also, you can't write the gradient is 3 over 2x. The gradient is just a number 3 over 2. Second question here. 2y minus 3x equals 8 passes through this point. So we know that y is equal to 13 at that point. That's the output. So if we put 13 into the equation, we should be able to find out what the x value is. 2 brackets 13 minus 3x is equal to 8. So 2 times 13 is 26. 26 minus 3x equals 8. Take away 26 from both sides, you get minus 3x equal to minus 18. Divide both sides by minus 3 and you get x is 6. So k is 6. If you have x is 6, then y is 13. Okay. Okay, next question then. So in this question, the most common error is to try and square the brackets, writing x squared minus 9 minus 10 equals 6. Please don't do this, it's just wrong. The reason it's wrong, well, let's have a look at an example. What if x is 1? We're saying that x squared minus 9 is the same as x minus 3 squared, so let's see if it is for an example. X minus 3 squared, well that would be 1 minus 3 squared, which is minus 2 squared, which is 4, if x is 1. If x is 1 in the second example, we get 1 squared minus 9, 1 minus 9 is minus 8. So in an example with a number, these two things are not the same, so you can't write them as the same thing when you're changing the algebraic expression. They are not the same, so you can't expand, you can't square like this. So they're different. So what we're going to say, we're going to rearrange it slightly differently. We're going to start from the question. We're going to add 10 to both sides to get 16. At this point, we will square root and we will get x minus 3 is equal to plus or minus 4. If you have the second test, you will have a decimal number now, and you'll have plus or minus the decimal number. And all you have to do at the end is add 3 to both of these options. So 4 plus 3 is 7, minus 4 plus 3 is minus 1. Because there are two options, two answers. Okay, let's look at the next question. Okay, so this is the final question. You could use a table of values if you wanted, and lots of you would have got most of these right, and just maybe been slightly confused with the question that you got the answer maths error. So maths error occurs because you end up dividing by 0. So you could say dividing by 0 is infinity, perhaps, or maybe a better way to write it would be undefined. So we can't define this here. So if you just left this blank, it would have also been fine. Okay, so if we plot the points that we know, we get 4, 16. Okay, and we could go through the points here. Notice how the pink line I've drawn kind of shoots off to infinity, because it never quite gets to infinity. So at minus 2, when I say it's infinity, the pink line will shoot towards it but never quite make it. If I've got the other points, okay, again, we will connect them with a line, and you can see it kind of shoots off to infinity again. And at minus 2, we could draw a dotted line here, and we might call this an asymptote. It's a line that the graph kind of never reaches. So this is not necessarily on the scheme of work, but we thought it would be interesting to test you, see how you did. Most people kind of drew a straight line between minus 2.25 and minus 1.75. If you did that, it's understandable, but that would have lost you 1 mark. Okay, well, thank you for watching. I hope that was useful. If you have any follow-up questions, you can always email me, or you can even send a tweet to #UCSMaths, and then one of the maths teachers will pick it up and respond to your question. Okay, again, thanks for watching. See you next half term.